Hello everyone, welcome back to my class. So today we are going to talk about U-substitution. We don't have that many integration rules. For quite a field of problem that we see, the rule don't directly apply. Especially, do you remember chain rules, which is we try to derivative of a composite function f of g of x. So the derivative of this composite function is going to equals to, we derivative the fx first at g of x, and then we will multiply the derivative of g of x. So when we integral them, how do we do the reverse? Remember, integral is basically, some people will call it antiderivative. So in that case, if we integrate this function, this is going to equals to the original function. Alright, so here is the method for integration. So if I want you to integrate x over square root of x minus x squared d of x. So when you look at this function, you need to think about that, hey, one of these is the derivative of fx function, the other one is the derivative of g of x function. So when we start this, we can remember earlier the example we used u. So let's think, which one would be u? Whatever u is going to be our g of x. So you can let either x equals to u or, oh sorry, I write this wrong, should be 4 minus x squared. Or you can let 4 minus x squared equal to u. So I think usually you will let the one that looked like a function to be equals to u. So the first step is you let u equals to 4 minus x squared. So now let's derivative of that. So when I derivative of u, so that means I take in derivative dx at du. So that means on the right side of the function is equals to 4 minus x squared and derivative. So that means du differentiate at x is equals to negative 2x. Okay, so that's very close. Why would I do that? Because you see there's an x and there is x. This is very close. So that means, okay, we pick the right u. All right. So what we're going to do is we try to figure out d of x is equal to what? So we know that du over d of x equals to negative 2x. So that means we do some function manipulation. We have dx is equals to du divided by negative 2x. Okay, so when we call this is U-substitution, that means we want to substitute, right? Okay, so now take a look at here. I have this part equals to u, and this part we just found that it's equals to du over 2x over negative 2x. So we substitute these two parts back into the function. So the first part is the highlighted denominator is equals to square root of u and then x. And then I have a dx because I substitute u equals to 4 minus x squared. And then for dx, and we found that in here, dx is equals to du over negative 2x. So we substitute that part. So I have x over square root of u equals to du over negative 2x. Now we can simplify it. So x and x, they cross cancel. I have u, square root of u, 1 over square root of u. I can write it as what? Negative 1/2 du, and negative 1/2. I can move it outside of the integral. So I have a negative 1/2 integrate negative u to the negative 1/2 power du. So now we can apply our integration rule to find the integral of that function, which is, well, I need to add 1 first, which is u 1/2, and then times the opposite, which is times 2. So this is the integration antiderivative of u to the negative 1/2. So simplify, I have this is equal to negative u to the 1/2. Alright, so now we need to substitute things back inside, because again, u is equal to 4 minus x squared. So I substitute that back, I have 4 minus x squared 1/2 power, which is negative square root of 4 minus x squared. Don't forget the plus c at the end of the integration. Okay, so how would we check these? Well, we can differentiate this back, see if we get the derivative is equal to this function. So let's do the check-in. So now I want to differentiate negative 4 minus x squared to the 1/2. Well, the negative sign I can just put out and then try to differentiate 4 minus x squared 1/2. And by chain rule, I got 1/2 4 minus x squared, and then 1/2 minus 1, which is negative 1/2, times whatever inside the parentheses, which is negative 2x. Well, when we simplify it, I have negative 2, and then I got negative and negative, I got past it, and so I have x 4 minus x squared negative 1/2. When we organize it, I have x over 4 minus x squared square root, which is the integration function that we got. All right, so now let me give you more examples. Another one is I want you to evaluate or integrate ex over ex plus 15 to the third power dx. So in this one, we need to set up our u first. Which one would you put as u? Again, usually I will just do here, the polynomial. Alright, so I let u equals to e to the x plus 15. So that means if I get the derivative of u, which is I du over dx, so I will get derivative on both sides at the same time. So this one, du over ds is equals to ux. So now we want to find out what is dx. So dx is going to equal to du over e to the x. Okay, so now we can do the substitution. I got e to the x, this part is equal to u to the third power over dx, because I substitute the u into our denominator. And then next part is you want to substitute the dx in here. So I have e to the x, u to the cubed, times du, e to the x. Now I can simplify it. E to the x power, they cross cancel. So I end up to have integration u to the negative 3 power at du. Now we can operate the function by using the rules that we have, which is equals to, we add 1 and pull the reciprocal, which is u 1/2, negative 1/2 to u to the negative 2 power plus c. Now we need to substitute the u back. U is equal to e to the x plus 15. So now we put this back. I have e to the x plus 15 to the negative power plus c. If you want to write it nicely, you can write it as negative 2 times e to the x plus 15 to the second power in the denominator, and then add c. Now we still want to check. So for checking, I want to differentiate that. So derivative of that. So I have negative 1/2 e to the x plus 15 to the negative 2 power, and then get derivative. So I have a negative 2, and now apply the chain rule, which is negative 2 times e to the x plus 15 to negative 3 times whatever the derivative of inside the parentheses, e to the x. So these two cross cancel, so I end up to have e to the x over e to the x plus 15 to the third power, which is our original function. So that means this is correct. So now let's try to do a couple more, such as this one. How to evaluate x squared over x cubed plus 5dx. Again, we use U-substitution. I let u equals to x cubed plus 5, so that when I get derivative of u on the right side of the equation is equals to 2x squared, which is x squared, then we might know, okay, the x squared might get cancelled out later. So ds is equals to du over 2 to the x squared. Now we do all the substitution. First of all, we substitute the u back. We have u in here, and dx, since now we're more familiar, we can just do the substitute together at one time, at du over 2x squared. Okay, let me label these. This is for the ds, and then this part is for the u. Alright, so now these two cancel. I can pull the 2 out, so I have 1/2 u to the negative at du. Now we can do the differentiate. So I have 1/2 negative 1/2 u negative 2 du. Okay, so next step is we want to rewrite this. So I have negative 1/4 u is equals to x cubed plus 5 to the negative 2 power du. You can leave it in this way, or you can write into a fraction. But living this way, it will be easier for you to check the answer. So now let's check. Well, I have a negative 1/4 x cubed plus 5 to negative 2. So when I get the derivative of this function, I would apply chain rule, which is I pull the power in front, so, and then subtract 1 from the power, and then times whatever the derivative of inside the parentheses, which is 2x squared. Now simplify it. All the 1/2 to this got cancelled out, so I end up with x squared over x cubed plus 5 to the cubic function, which is the same as our original function. Okay, so let's compare this one to this one. Okay, so for the second one, well, you may try to say, okay, I want to use the U-substitution to solve that because we just learned U-substitution. But in fact, we don't need to do that. Don't just because you learn something and you forgot something that we learned, we can always try the easiest way to solve it. So for this one, we can separate the numerator. So I have x cubed over x squared plus 5 over x squared at dx. So after I simplify it, I got x plus 5 times x to the negative power dx. Well, by the property of integral, we know that this is equivalent to, we integrate the ds, the x at ds, and we can separate a big integration into this part. In fact, I can pull the 5 out, right? The 5, they can stay outside of the integration. Look like this one. So when we integrate the first one, I got 1/2 x squared plus, this one is negative 5 over 3. Don't skip that. When you integrate those, I have 5 times negative 1/3 x to the negative 3 power at c. Don't forget to add c. I may forgot to add c in the earlier function, which is in here. This already doesn't have du. I should go back to add c, the constant term. Okay, so now after we've done this, let's go back to our U-substitution. Let's try to do the integral with defined integral, which is, let's say I want to integrate from 2 to 10 ln of x to the 6th power over x at dx. Well, we need to pick our u first. In this one, I will do u equal to ln to the x, because when we get derivative of u, I will get 1 over x, which is in here, so that our dx is equals to, you multiply dx on both sides, and we get x times du. Alright, so now let's substitute that into our original integration function. So I have from 2 to 10, ln of x is equals to u to the 6 over x. dx equals to x times du. So simplify, I have a u to the 6 du. Now we can do the integration, which is 1/7 u to the 7th power from 2 to 7. From 2 to 10, sorry. Now the next step is I substitute the u back and try to figure out, hey, from 2 to 10, what is the answer? So our u is equals to ln of x to the 7th power. So the answer should be ln to the 10 7th minus ln to the 2 7ths. You can use the calculation to give you the exact number, or you can just leave it as is. So if you use a calculator, this is approximately equals to 49.01. So that's it for the U substitution. Let me know if you have other questions. See you next time.